Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a new topic. The topic in name is DIT FFT, that is Decimation in Time Fast Fourier Transform. Basically, what do you mean by decimation? Decimation means divide. Now, what we are going to divide? Basically, if we want to find out a DFT for n point, then it will be difficult and the lengthiest process. That's why we prefer a radix to DIT FFT approach. In this radix to DIT FFT approach, we are going to divide our sequence into number of smallest set, and then we are going to perform DFT on it. So let's see how we are going to divide this set, or how we are going to perform a smallest set, and how we will get the answer but in DFT. So we will start the derivation part. Now, suppose I am having one function that is x of n, and it is having total n points. But in this n points, some points are even and some points are odd. In x of n, some of the points are even and some of the points are odd, which means we can divide our function at the start into two parts. The first slot is for even terms or even samples, and the second slot is for odd samples. So, as I discussed, we can divide our sequence into two parts. The first slot is for even and the second slot is for odd, which means our total n is basically now divided into two parts. So, what I will get for even parts, how many samples we have? N by 2, as well as for odd part also we will have the same n by 2 samples. But listen, our counting always starts from 0. Which means our samples, if we are considering only a causal sequence, or if we want to discuss only causal sequence, then our counting always starts from origin, that is 0. And if we have n samples, which means the last sample value is always placed at n minus 1. So if we want to divide these numbers into odd samples as well as for even samples, then our sample value, the last sample value, is always n by 2 minus 1. If our counting starts from 0, and if we are going to divide the samples into two parts, then the first of all, the last limit is n by 2. But if our counting starts from 0, then the last limit will be n by 2 minus 1. And this will be limit for even samples as well as odd samples. So let's say I'm going to divide my function into two parts. Let's say f1 is my even term, or f1 is the function for even values or even samples, and f2 of n is nothing but my samples for odd values. Now, as I discussed, our function is divided into two parts, even part and odd part. So, if we want to write even part, then we will always multiply our n by 2. And if we want to calculate odd part, then we will always add 1 in 2n. So my f1 function is for even samples and f2 of n is function is for odd samples. And as I said, my sample value start from 0 and the last limit is always n by 2 minus 1, which is similar for even as well as odd. Now I'm going to write the definition of DFT. Summation n value varies from 0 to n minus 1. This is the last limit. X of n into omega n raised to k n. This one is the 12th factor. Now, as we discussed, our x of n is divided into two parts. The first one is even function, that is f1 of n, and the second function is f2 of n. So I'm going to split these summation limits or summation value into two parts. The first part is for even values and the second part is for odd values. Now, I'm going to substitute my f1 of n and f2 of n, that is my x of n value in these two summations. Now, what I'm going to do, I'm going to substitute my x of n values, that is even sample values and odd sample values in these two summations. The even value or the x of n values for even is represented by x2 of n and the odd values is represented by x2 of n plus 1. Now, in both the cases, my n value varies from 0 to n by 2 minus 1. So, this summation limit starts from the lower value is 0 and the upper value is n by 2 minus 1. And the first I'm going to write the even. So, we'll substitute here x of n values by, or we'll replace this x of n value by x2 of n. Now, as this n is replaced by 2n, of course, then this small n is also replaced by 2n. Similarly, on second side, here I'm going to substitute the odd values, which means this x of n is replaced by x of 2n plus 1. In short, we can say that this n is replaced by 2n plus 1. So, this n will also replace by 2n plus 1. The summation limit value is same, that is it starts from 0 and the last value is n by 2 minus 1. Now, what I'm going to do, I'm going to keep these two inside. Here also, I'm going to first of all separate this omega n raised to k value, or we can say this whole order I'm going to split into two parts because it is in addition form. And we know that a raised to a plus b is always a raised to b into a raised to c. So if I multiply this k inside this bracket, then what we will get? Omega n in power we have 2nk and in second we will have only k. So we'll split these last powers. As I said, I'm going to keep 2 inside and this k and I'll keep it on outside. Similarly, here I've multiplied k inside the bracket. So what I've got 2nk plus k. Now I'm going to split these powers. So if I split this power, then we can write this last term as omega n to the power 2nk into omega n raised to k. And we have studied omega n to power 2 is always omega of n by 2. This x2 of n, this function is represented by f of n or f1 of n. And as I said, this omega n raised to 2 is replaced by omega n by 2, and this kn will be written as it is. Now this x of 2n plus 1 is represented by f2 of n. I'm going to split these orders. Now basically this last term is independent on this summation value, or you can say it is a constant term. So we can write this constant term outside the summation. Now we will do the same thing which is we have done over here. I'm going to keep 2 inside and I'm going to write kn outside. Here also we'll do the same thing. First of all, I'll write this constant part outside. And we have calculated this value, which is omega n by 2 only. Now we can say that our equation is present in the definition format. This is nothing but the definition of DFT when we have a sequence value up to n by 2. This one is also similar to definition of DFT. So we can directly write this whole part is replaced by f1 of k, and the second part is replaced by f2 of k, and this f2 of k is multiplied with omega n to the power k. Now this was our equation. X of k is nothing but f1 of k plus omega n to the power k f2 of k. Now our answer is converted into DFT, which means here the sample value is represented by k. Then what will be the limit of this sample value? Of course, we have divided the sample value into two parts. So this k value will also get divided into two parts, but first one is for even, the second one is for odd. But if we going to add both the values, then our limit will be 0 to n minus 1. If we are going to divide it, then our value will be 0 to n by 2 minus 1. And here I am going to add both the values, that is the even value as well as odd value. Then you will get the complete sequence. So here my k value varies from 0 to n minus 1. Now what I'm going to do, I'm going to add some delay in even part as well as in odd part. That is, this k is delayed by n by 2. Similarly, this f2 of k is also delayed by n by 2. So which means all these k's are delayed by n by 2. So this k and this k replaced by k plus n by 2. Now if we delete both these values by n by 2, then we have studied one thing. If k plus n by 2, if we add n by 2 delay in my function f1 of k, then my result is always f1 of k, and this one is also f2 of k. Basically, why we are adding delay? Reason is, I just want to calculate the even sample and odd sample values for this x of k also, because if you will get only 4 sample values, that is even value, and if you want to calculate next even values, if we have 8 samples and we are going to divide the samples into smallest set, let's say I'm going to divide into 2 smallest set, so you will get the answer only for 0th sample and the 2nd sample. How to get the values for 4th sample and 6th sample? So to get that next value, we will add n by 2 delay in our function. So this k is also replaced by k plus n by 2, or you can say the all k which is mentioned in equation number 1 will be replaced by k plus n by 2. Basically here I'm trying to discuss the 8-point DFT. So that's why I said my even samples are 0, 2, 4 and 6. If this k is replaced by k plus n by 2, then of course all this k will be replaced by k plus n by 2. Now f1 of k plus n by 2 we have discussed, it is similar to f1 of k. Similarly f2 of k plus n by 2 is always f2 of k. But omega n to the power k plus n by 2, we can split this order. So what you will get? Omega n to the power k and omega n to the power n by 2. Now omega n to the power n by 2 is always a minus 1. So this is nothing but my equation number 2. And on this basis, that from using equation number 1 and equation number 2, I'm going to plot the structure or butterfly diagram for DIT 8-point DIT FFT. So basically our function is divided into two parts, even part and odd part. Then what is the value of sequence which comes in f1 of k and in f2 of k? So what was my f1 of k, or what was my f1 of n? It was 2n, and this f1 of n is calculated only for even values. So if I substitute n equals to 0, then what we will get? 2 into 0 is 0. Or simply you can say this f1 of k is calculated only for even values. And if we are calculating this DIT FFT for 8 point, then you will get the answer of even samples only in f1 of n. So even sample values are next. Similarly, my f2 of n, this was the equation for odd samples. So we have already calculated this x2 of or x of 2n value. Only one thing is remaining, which is we are going to add 1 in each and every sample. So if we add 1 in each and every sample, you will get the answer for odd one. Now, so here from this you can say that you will get the answer for 0, 2, 4, 6 values or sample values in f1 of n and 1, 3, 5, 7 values in f2 of n. Now here the answer in DFT is also divided into two parts. The first part is for even, the second part is for odd. So here I am going to substitute only the even values, that is 0 to 4. So let's see what will be the result. If I substitute k equals to 0, then this k, all this k value will be replaced by 0. Now here I have considered I am having 8 points. So this n is replaced by 8. Now I'm going to substitute the next value for k, that is 1. So all this k replaced by 1, and this n, as I said, I'm calculating for 8-point DFT, so this n is replaced by 8. So I'll calculate the next two values also for k equals to 2 and k equals to 3. So the x of k, first 4 samples, that is 0, 1, 2 and 3. This first 4 sample can be obtained by just adding f1 of n with a product of omega 8 to the power k x2 of k. I'll repeat, if I want to calculate the first 4 sample values of x of k, then we will simply add f1 of k plus omega n to the power k f2 of k. Only thing is this k is replaced by 0, 1, 2, 3. So here I have substituted my first 4 sample values, and according to that I have got this equation. Now here my f2 of k value is always multiplied by omega n to the power k. So here I'm calculating this whole calculation only for 8 points. That's why this n is replaced by 8. And here the k value is replaced by 0 to 3. Now there is one butterfly diagram which is normally drawn for DIT FFT. So I'm going to place all this calculation on my butterfly diagram. So let's see how it looks and how to get the answers. Now this is my 2 points or the 8 points which is divided into 2 plots. The first one is for 4 sample, next one is for 4, which means at the end here I will get the answer but in DFT format, that is I'll get the answer in x of k. So the first sample value is represented by x of 0 and the last one is x of 7. So I'll fill the rest of the values. Basically x of 0 is calculated by using f1 of 0 and f2 of 0. But basically where is f1 of 0 and f2 of 0? As I discussed, we are going to divide our samples into 2 parts. The first part is for even, the second part is for odd. Which means this first point or this first n by 2 points DFT is calculated only for even part and the second part is calculated for odd part. So this is nothing but my f1 of 0. The output of this whole result is in DFT, and here I have substituted my k value which is 0. Similar, the second part is for odd, so here I'm going to write basically all the values of f2 is multiplied by omega n, or that is omega 8 to the power k, and the k values we have already placed over here, that is 0 to 3. So we'll multiply this all the values by now. How to get the value of x of 0? Now how to get the value of x of 0? The x of 0 value is obtained by just adding f1 of 0 with a product omega 8 to the power 0 f2 of 0. Similarly, x of 1 is obtained by adding f1 of 1 with a product omega 8 to the power 1 into f2 of k. This f2 of k value is 1, so this equation is replaced by or represented by. Now for x2 of k, it is the addition of f1 of 2 plus a product omega 8 to the power 2 f2 of 2, and the last one is this, which means the first line of the even part is calculated by just adding it to the even part with a product of odd part. So I'll show you where you will get the answers. So as I discussed, our x of 0 is value is obtained by just adding f1 of 0 and the product of f2 of 0 with omega 8 to the power 0. If we mark one arrow on any line and if we are going to write a value on it, then this value is multiplied with this line, and whatever result will be there, it will be present after this arrow. So basically x of 0 is addition of f1 of 0 and the product of f2 of 0 and omega 8 to the power 0. Similarly, x of 1 is addition of f1 of 1 with omega 8 to the power f2 of 1, and similarly the next two is also added with these two lines. So I'll just connect all these 4 lines with f1 of 0, f1 of 1, f2 of 1 and f1 of 3. And basically all these lines will be added with so after adding you will get the first 4 sample values. Now how to get the next 4 sample values? So we will use the second part, that is x of k plus n by 2 equation. Now this was the equation number 2. Here we have calculated only first 4 sample, that is 0 to 4. Now how to get the next values? Basically we have divided our input sequence into 2 parts, that is for even and odd. So if we add the delay in this x of k equation, then we have got this answer. Now here as I said, my n value is 8, so 8 by 2 answer is 4. So which means all the sample values, that is all the values of k will be added with, or this k value is added with 4. So I can directly write this n value is 8, so 8 by 2 is 4, so all the k values will be added with 4. Now we have already calculated that 4 sample values, that is 0 to 3. Now we are going to calculate the next sample values, that is next 4 sample values. So we will again add the k values, or we will substitute the k values from 0 to 3. So for k equals to 0, all this k is replaced by 0. What you will get? 0 plus 4 is 4. So in first case, in first half, we have added f1 of 0 with these 2 products. So now in the next part, that is if we want to get the answer of x of 4. But in second part, if we want to calculate the answer of x of 4, we are going to subtract this product from f1 of 0. Now how to subtract this value, I'll show you later on. But first of all, we'll calculate the next 4 values, or we'll substitute all the k values from 0 to 3. Now these are the calculations we have done. Now I'll substitute all this calculation but in graphical point of view. So let's see what will be the effect, or how we are going to subtract this product from f1 of 0, f1 of 1, f1 of 2 and f1 of 3 to get the answer of next 4 sample values of x of k. Now after this product, or after this line, if I multiply all the lines by -1, then what will happen? This whole product sign will be changed to minus. Only the thing is, we are going to add all the above 4 values with next 4 values. But the thing is, here we place a adder sign, but we are going to multiply this whole product by -1. So of course this whole sign or whole product sign changes to -1, and minus plus becomes minus. So automatically this whole part, that is product f2 of 0 omega to the power 0, is subtracted from f1 of 0. The same thing I'm going to do with the next 4 samples. So automatically the sign of all this product term will be changed to negative, and now x of 4 is the simply addition of f1 of 0 with this whole product. So the first line is connected to x of 4, the second line is connected to x of 5, similarly second, third to third, and the fourth to fourth. So like this you will get the answer of x of k, that is you will get the answer of 8 point but in DFT format. But f1 of 0 we have calculated, f1 of 1 we have calculated. So again, similarly we have calculated the DFT of even part and odd part. But what is the value which is present at the input side. So f1 of 0 is a DFT of f1 of n. Simply, this is the DFT of f1 of n. Your result is obtained in f1 of k, which means at the input side you have written f1 of 1. So this value is 0 for 0th sample, this value is 1 for first even sample, this second value is for second even sample, and this fourth value is for fourth even sample. And we have calculated all the sample values. So I'm going to directly put this all the sample values on input side. Similarly, we have calculated the odd sample values also. So this is the first half part of 8 points. Now again we are going to divide these 4 parts into two smallest part, because as I said, this 8-point DFT or the DIT FFT is nothing but we are going to divide all the 8 points into a smallest set of DFT. So this is the only first part we have done. Now we are going to divide again this part but into two smallest DFT. So let's see how to do that. Now I'm again going to divide all my even samples and odd samples into two parts. So let's say my f1 of n and f2 of n is again divided into even part and odd part. So how to write the even and odd values for f1 of n, f2 of n? Let's see how I will show you. Let's say my u11 of n is nothing but the even values of f of or f1 of 2n. Similarly, for odd values, we can write f1 of 2n plus 1, and this can be represented by u12 of n. Now we will do the same thing with a next odd sample, that is f2 of n. Now f1 of n is actually the even values of x of n. That's why we have divided our whole n sequence into two parts. So our starting limit was 0 and the ending limit was n by 2 minus 1. But if we again further divide my f1 of n into two parts, then my n by 2 is again divided by 2. So my limit will be now, the last limit will be n by 4 minus 1. So for all these u11, u12, u21 and u22 values, my n value start from n by 2 minus 1. That is n by 4 whole minus 1. Now we will substitute this value in my equation and I'm going to find out the DFT of u11, u12, u21 and u22 of n. If I want to calculate the response of f1 of k, then as I said, f1 of k is a combination of even part and odd part. Even part is represented by u11 and odd part is represented by u12. Similarly for f2 of k also, it is again divided into two parts. So the even part is represented by u21 and the odd part is represented by u2 of k or u2 of n. We have divided my f1 of k value into two parts, that is even part and odd part. Even part is represented by u11 and odd part is represented by u12. Similarly, my f2 of n is also divided into two parts, u2 of 1 and u2 of 2 or u22 of n. So if we are going to find out the DFT of both the sequence, that is f1 of k and f2 of k, then how we are going to represent it, I'll show you by equation. Now, the DFT, basically f1 of n is addition of u11 of n and u12 of n. But if you're going to find out the DFT, then the response will be u11 of k plus omega n by 2 to the power k u12 of k. Why I have written n by 2? Reason is, the first part is we have calculated the x of k, we have calculated for 8 point. But right now, before starting this part, our second half, we have said this 8 point is divided into two parts. That's why we have divided this n by 2. So, if this n is divided by 2 and if we are doing the calculation for 8 points, then this n is replaced by 2. So, 8 by 2 is 4. So, this whole part is replaced by omega 4 to the power k. Now, here also we are going to add the delay. So this k is added, or the delay is added in k, which is not n by 2. Now it will be n by 4 because n by 2 is for first half section. Now here again we have divided the sample into two parts, so that delay will be n by 4. But first of all, we'll write the equation for f2 of k. Now I will add a delay in both the parts. So basically our k is replaced by k plus n by 4. So all this k will be replaced by k plus n by 4. But k plus n by 4 is nothing but u11 of k. Similarly, u12 of k plus n by 4 is again u12 of k. So I can write, and omega 4 raised to k plus n by 4 is minus of omega 4 raised to k. So if we add the delay in f2 of k, the whole thing will remain same. u11 is replaced by u12, u21 is replaced by u22, but this sign will be changed to minus. Now we are going to add the k values. Basically, what will be the value of k? In first half, our k value is 0 to n minus 1. But as the samples are divided into two parts, then this k value will start from 0, but the last value is now n by 2 minus 1, which means here if the n value is 8, which means we can calculate our sample values of k, but from 0 to 3 only. We will do the same thing over the next part, or in the next part. So here also my k value starts from 0 and ended up to at 3. Now we will substitute all the k values in my first part as well as in my second part, and from that I will draw the next butterfly diagram. Now basically our samples are now divided into 4 parts. So my this k value is also divided into 4 parts. So 8 by 4 result is 2, which means here we can substitute only the values of k, but from 0 to 2. So first of all we'll substitute k value as a 0. Then this whole equation can be written as now the next part is 1. So all these k values are replaced by 1. Now what about delayed part? So here also we'll substitute the k values, that is it varies from 0 to 1. So first of all for k equal to 0. As this n value is 8, so 8 by 4 is, answer is 2. So this 0 will be added with 2. The answer always will be f of, but all this k is replaced by 0. So what is my equation? Now if I add 1 over here, then 1 plus n by 4, that is 8 by 4 is 2. So 1 plus 2 is 3. Now from these two equations, I'll draw the first part of DFT. Now f1 of 0 is achieved, or you can get the answer by just adding u11 of 0 plus the product of u12 of 0 with omega 4 to the power 0. And f1 of 1 is obtained by adding u11 of 1 with a product of omega 4 to the power 1 u12 of 1, which means to get the value of f1 of 0 and f1 of 1, we have to add u11 of 0 with u12 of 0, this whole product term we are going to add with u11 of 0. Similarly, the next product term is added with u11 of 1. So let's see how to get the answer, but in graphical way. Basically, f1 of 0, as I said, it is addition between u11 of 0 and this product term. So simply just connect this line to this addition sign. So what do you mean by this? u11 of 0 is added with a product of u12 of 0 omega 4 to the power 0. Similarly, f1 of 1 is addition between u11 of 1 and u12 of 1. So simply take this line and connect it over here, so that automatically this product term is added with u11 of 1. So from this you will get these two values, but now we have to calculate the next values, that is f1 of 2 and f1 of 3. So let's see the equation first, and then you will get the idea how to get the answers. Now f1 of 2 is a simply subtraction between u11 of 0 and this product term, or simply you can say that this product, that is omega 4 to the power 0 u12 of 0, is subtracted from u11 of 0. Then you will get f1 of 2, which means both these equations are same. Only the thing is, if I multiply this product term by minus sign, then you will get the f1 of 2. Similarly, if I multiply the minus sign with this whole product term, then automatically you will get this answer, but for f1 of 3. So I will show you how to do that, the next part. So as I said, if I multiply minus sign, but after this dot, then this whole product after this dot is multiplied by this minus 1. So minus into plus, answer is a minus. So automatically, if we connect u11 of 0 value over here, then this whole product term gets subtracted from u11 of 0. Similarly, if I connect u11 of 1 over here, then automatically this whole product term is subtracted from u11 of 1. Now similarly, we can do the same thing with next half part also, which means these two next values is added with the first two values to get the answer f2 of 0, f2 of 1. Similarly, if we multiply minus sign but after that dot, then these two values will be subtracted from u21 of 0 and u2 of 1 to get the values of f2 of 2 and f2 of 3. What is u11 of n? u11 of n is nothing but f1 of 2n and f1 of 2n plus 1. So f1 of 2n is nothing but my x of 4n. So if we add 0 and 1 value over here, then you will get x of 0 and x of 4, which means in u11 of n, you will get the answer only for x1 of 0 and x of 4. So next two values of x of n samples are placed over here, that is x of 2 and x of 6. Similarly, u21 of n is f2 of 2n. Basically, f2 of 2n was the odd part of x of n. So you will get x of 4n plus 1. Now, if I substitute n equals to 0 over here, then 0 plus 1 is nothing but x of 1. And if we add 1 over here, then 4 into 1 is 4 and 4 plus 1 is 5. So next odd sample is x of 5, which means the first two parts of the answer is having two samples, that is x of 0, x of 4. The next part is having x of 2, x of 6. Here also we have the x of 1, x of 5. And what about next odd part of x2 of n or x of n? This was the odd part of 2n plus 1, and f2 of n is the odd part of x of n. So we can write this expression as 4n plus 3. Now, if we add 0 over here, then 0 into anything is 0 plus 3 is x of 3. And if we place over here 1, then 4 plus 1 is 7. So I'll substitute all this value in my butterfly diagram so that you will get the idea which term is placed at the left hand side of n by 4 point DFT. So the first two values of first even part was x of 0 and x of 4, and the next values are similarly fill the next two. So this was the first half part, and we have calculated the second half part in first part. Now I will draw or I will connect all these diagram back to back. Now we will find out the DFTs of first part. Basically, while starting the derivation, we have calculated the output part first. But how to get the output? We have divided our input sequence into two parts. After that, we again divided our sequence into two parts. So 8 point is divided into 4 and 4 point is divided into 2. So we have seen the calculation between 8 points and 4 points, but we have not seen the calculation between 2 points. So we will find out the same one. We'll find out the calculation between 2 points. So first of all, my u11 of k value is, basically we have a 2 points, so we can directly use the definition of DFT. As we have 2 points, 0 and 1, so this n is replaced by 2. Now, we have the 2 points, which means you will get the answer only for 2. So my k value is also varies from 0 and 1, or you will get the values of 0 and 1 only. So first of all, we'll calculate u11 of k value for k equals to 0. So all these k replaced by 0. So 0 into anything is 0, and anything raised to 0 is always 1. And I'll substitute the value omega 2 to the power 0 is always 1. Now I'll break this summation. So I can say that I'm going to substitute my n values, that is 0 and 1. So u11 of 0 is the result of u11 of 0 plus u11 of 1. Now we will calculate for k equals to 1. So all this k replaced by 1. We will substitute my n values. First of all, or you can say I will break this summation. So first of all, I will substitute n equals to 0 and then we'll substitute n equals to 1. Now this n is replaced by 0, then omega 2 0 value is 1. So we have only this value. Then next, this n is replaced by 1. And we have omega 2 to the power 1. Now omega 2 of 1 is always minus 1, which means this sign is changed to minus sign. So my u11 of 1 is the subtraction between u11 of 0 and u11 of 1. So how to draw a butterfly diagram only for first part or only for first 2 points? As I said, you will get the two answers, u11 of 0 and u11 of 1 from u11 of k. And this u11 of 1 answer is obtained from u11 of 0 and u11 of 1. So I can say that here we have. Now, to get the u11 of 0, we have to simply perform the addition between these two inputs. So simply look at here. So look at here. Here I will place a adder sign. Here also we will place the adder sign. Now, if this point will directly connect to adder, so I can say that u11 of 0 is added with u11 of 1 and you will get the u11 of 0. According to this statement, we can get this graph. But here we have to do the same thing, but u11 of 1 is multiplied by minus sign, which means if I multiply this whole line by minus sign, but after this dot, then u11 of will carry the minus sign and this will be added with u11 of 0. So I will take one line from upper side. I will connect it with this. And this is the diagram for 2-point DFT. So for next all the values of u12 of k, u21 of k and u22 of k, we will use the same pattern and I will draw a final structure of DFT or the DIT FFT. So let's see what is the outcome. So this was part we have calculated, and as I said, we will do the same thing for next samples also. In first session we have calculated the last half or last part. Then in second last session we have calculated this part, and in this last session we have calculated the first part. And this is the butterfly diagram for 8-point DIT FFT. Now we will solve some few numericals which is based on 8-point DIT FFT, and then later on we will derive the same thing. We will draw the butterfly diagram for DIF FFT, that is decimation in frequency fast Fourier transform. So thank you for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.